Alright, here's a system of equations that we're going to solve, and the first thing to do is kind of take a look at it and see which variable that you feel like eliminating. Now there's no wrong answer to this, but sometimes some of the variables are easier to eliminate than others, and for this one I'm going to say that the y's are going to be the easiest to eliminate, because you already have, and we'll call this the first equation, the second equation, and the third equation. And so if you're looking at your y's in all three equations, you notice that in the first and second you already have the same coefficient of 1 and the signs are opposite, and then the third equation is just a simple number 2. So the first thing I'm going to do is take the first two equations and add them together. So I'm going to write them off to the side. X plus y plus z equals 6. 2x minus y plus 3z equals 9. And again, we have the y's as a positive 1 in the first one and a negative 1 in the second. So we're just going to add straight down. So you get 3x, the y's cancel, plus 4z equals 15. Okay, and I'm going to call this the fourth equation. Now we're going to have to use the third one, and we can use either the first or second one when we do that. And I'm going to choose the second one because, again, the y has a negative in the second one and a positive in the third one. I'm going to end up multiplying the second one by 2. And make sure you do this step right. So you should get 4x minus 2y plus 6z equals 18. Again, we're going to add these straight down and get 5x, the y's cancel, plus 8z equals 27. And we're going to call this the fifth equation. Okay, now all we're doing is looking at the fourth and the fifth equations. And we have an x and a z in both of them. And so this is just solving a system of equations, two unknowns. You can do this by any method that you wish. You have the option of substitution, elimination, or Cramer's rule. I'm going to just stick with elimination. I think that's the easiest one, and it's a good one to practice because you have to watch your signs. And I'm going to choose z's to eliminate because all we have to do is multiply the fourth equation by negative 2, and that will get us a different signs with the same coefficient for our z's. So I'm going to, again, multiply this one by negative 2. And what we get is negative 6x minus 8z equals negative 30. We add straight down and get negative x, z's cancel, equals negative 3. And so then we get x equals 3. Alright, we're going to plug this into either the fourth or the fifth equation for x, and I'm going to choose the fourth. And again, it doesn't really matter on this. And I'm going to write this out. So it should be 3 times 3 plus 4z equals 15. That gives us 9 plus 4z equaling 15. Subtract 9 from both sides. 4z equals 6. And z equals 3/2. So now we're going to take these two solutions and plug them into either of the first three equations. And I'm just going to pick the first one, and again, it doesn't matter. And plug in x as 3 and z as 3/2, and find out what y is. So again, x is 3 plus y plus 3/2, and that equals 6. Okay, so this is the same as 6 over 2 plus y plus 3/2 equals 6. So 9 over 2 plus y equals 6. And when we subtract 9 over 2 from both sides, it'd be like y equals 12 over 2 minus 9 over 2. So y equals 3/2. Okay, so remember x was 3 and z was also 3 over 2. So these are our three solutions. You can plug them into the first three equations and they should end up all working out.